the top, if you have, from factoring, you can factor a difference of squares. X squared minus y squared is called the difference of squares, and it factors to x plus y, x minus y. And we call these conjugates. Okay? These names are important because the strategy, and I'll write that out here. Look at all these math words we have to put into this strategy. If you have a denominator, that's the bottom of your fraction, that is a binomial. Two terms makes a binomial. With square roots, comma. If that's the case, which we do here, we have a denominator, that's a binomial, two terms, and there's square roots involved. We have a square root of 2. The strategy is you can rationalize by multiplying by the conjugate. Oh my goodness. I'm going to just take out my highlighter. When we learn new definitions and new things in math, okay, in this strategy, I think there are 4 words that you use almost exclusively only in mathematics. And I'm not going to, like, multiplying, I think, is so basic that you could use that in regular, like if you were talking to your cousin and you said the word multiply, your little cousin, you wouldn't feel bad, right? If you were talking to your little cousin about denominators, they might look at you and go, I haven't learned that word yet. If you talk about rationalizing, they have no idea what a rational and irrational number is. They have no idea what a conjugate is. They have no idea what a binomial is. There's a lot of key math words in this strategy. Because there are so many key math words in this strategy, this is the number one thing in this unit people forget how to do. Because they don't know the math words, so it's very hard to remember the strategy. So learning the definitions helps us remember how to do things. So what does that mean for our question? Well, if I had 4 plus 2 root 6, and I have a denominator that has a binomial and there's square roots involved, then I need to multiply by the exact same thing, but the conjugate means it's the opposite sign. Very important that it's the opposite sign. And if I multiply that on the bottom, I have to multiply that on the top. These are in brackets, multiplied by these. You don't have to write the brackets there because the fraction automatically implies that, but it's not bad to write the brackets. What does this do for us? Well, this is where you go. I think it was simplified enough, Mr. JR. I'm okay with square roots on the bottom. But unfortunately, historically, mathematically, you can't have square roots on the bottom. And so, we have, in this situation, the bottom is a difference of squares. Oops, the whole reason we multiply by the difference of squares is it makes the first one squares. If you square the first one, 3 times 3 is 9. Root 2 times root 2 is 2. 9 times 2 would be 18. If instead you want to write 9 root 4 first so you make less mistakes, perfect. It's a difference of squares, so there'll be a minus sign here. What is 4 times 4?
16.
16. On the top, you would have to distribute everything. Four times 3 root 2, 12 root 2s. 4 times 4, 16. 2 times 3 is 6. Root 6 times root 2 would be root 12. And 2 times 4 would be 8. And root 6 times the only root, so it'd just be 8 root 6. Are we simplified? No. Do we have like terms on the bottom? Yes. 18 minus 16, we can definitely simplify that. Why is this showing? Can I make that go away? Okay. Usually I have that little extend the page button, right? And now it's getting hidden by this. It went away. There we go. I don't know what I did. I wish I did. Okay. 18 minus 16 is 2. Can I simplify anything in the top? Are any of them like terms? Can any of them be reduced further?
It is square root of 12, square root of 4 times square root of 3.
Yes. So the square root of 12 is root 4 times root 3. And since the square root of 4 is 2, you can bring the 2 out. That changes to 12 root 3. Okay. Now, good. You took all of them. Do you see now in your square roots, we got root 2, root 3, root 6. Can any of them be reduced? No. You're adding and subtracting on the top. Do we have any like terms? Any like radicals? No. Okay. Are we done simplifying? No. What else can we do?
Divide everything by 2.
We can divide everything by 2. You see we're dividing by 2? All of these can be divided by 2, leaving us with 6 root 2s plus 8 plus 6 root 3s plus 4 root 6s. And the bottom divided by 2 would be all over 1. Here is our final answer. Lots of mental math, lots of times table involved in these questions. So for simplifying, no square roots on the bottom. That's our new one. Mixed radicals in lowest terms. We need to make sure that we've combined all the like radicals in like terms. And in fractions, if you can divide everything by something, you need to do that, so that your fraction is in lowest terms. Whew. Okay, let's do, here I'll open a new page. Let's do B on a new page. We've got 2 root 3 minus 4 root 6. And on the bottom, we have 3 root 2s plus 2 root 3s. We have square roots on the bottom. Okay? We have a binomial on the bottom. To get rid of square roots on the bottom with a binomial, you have to multiply by the conjugate. What does the conjugate mean? Exactly the same thing, but a different sign in the middle. You have to make that difference of squares. That means our bottom is going to be 9 times 2, 18, and 4 times 3, minus 12. We got rid of our square roots on the bottom completely. On the top, it's this times this. So we need to multiply it all out. which will give me 2 times 3, 6, root 3 times root 2, root 6. 2 times -2, -4, root 3 times 3. Sometimes you can write this because you get too far. You're like, oh, root 3 times 3 is 3. So I'm just going to write 4 times 3. I can change it to 12 later. Everybody okay with that? Then, -4 times 3 minus 12, root 6 times root 2, root 12, and -4 times -2 plus 8, root 6 times root 3, root 18. The bottom is just going to be 6. Can I do anything with 6 root 6? No. So I'm going to just rewrite it for now. Can I do something with 4 times 3? Yes. It's 12. Can I do something with -12 root 12? Yes, you could bring the 4 times 3, means you could bring a 2 out, minus 24 root 3. Can you do something with root 18? Yes, it's 9 times 2. The 9 comes out as a 3, 24, you're left with a root 2. Okay. Can I do anything else with my top with the square roots? No. Are any like terms? No. Is there something you can divide everything by?
6.
You can divide everything by 6. We got root 6 minus 2 minus 4 root 3s plus 4 root 2s. This would all be over 1. There is my final answer. Simplified. Circle question 10 and 13. I. Can you see that you're going to need lots of practice with these? And that it's probably going to take you maybe until you're practicing the 10th, 11th, 12th one that you stop making little mental math mistakes. One mental math mistake makes the whole thing disastrous. And it takes practice. You will make mental math mistakes. So don't get frustrated if they're wrong the first time. If they're wrong the first time, that means do it again, but a little bit slower. You went too fast and made a mental math mistake.